Okay. So good afternoon, everyone. This is Samarth, and as you are aware, that we'll be continuing our discussion over differentiation and its application. And the major part of differentiation is like taken up by maxima and minima. So we'll see what maxima and minima is. Though we did study a maxima and minima in our previous classes, but we'll discuss maxima and minima in detail from now. So what we have here is maxima and minima are the interior points of the interval A and B. Okay. So what we have here is that it's a graph given to us, right? And the maximum and minimum of the graph is the maximum and the minimum point of the graph. Similarly, if a graph is given like this, so the maximum point is at the starting point and the minimum point is at the x is equals to b point, because it is a continuously decreasing graph, right? Again, there is another graph that we have. These are basically examples of what a maxima and a minima would look like for different graphs. For example, the first one is a continuous polynomial graph that we can see. So we have a peak there, so that is one maxima. Then we have a continuously decreasing graph. So decreasing graph, so the first point is the maximum and the second point is the minimum. And then we have an absolute value graph. So the other point is the maximum and the other point is minimum. So it's very easy to understand what the maximum and minimum of a function looks like from its graph. But to calculate them mathematically could be a point of discussion, that how do we calculate which point would be the point of maxima or the point of minima. So as you can see, there are multiple points of okay. So we were discussing here maximum and minimum, but maxima and minima are different from maximum and minimum. So see the here as it states here that there can be many maximas and many minimas, but there would only be one maximum and only one minimum. That is very easy to understand because see this is a point of maxima, because how did we define maxima earlier? Maxima was a point where you see a change in slope. That is, a slope of the graph becomes zero, right? And and there is a concave nature of the graph at that point. So we'll discuss more properties of what a maxima looks like in further discussion. But this is the point of maxima and this is the point of minima here. But this is the point of minimum, this is the point of maximum. I'm not sure if it's true or not, but we'll see. Maxima is true, but minimum is not. So we'll see what is the point of discussion here. So see again, the condition for a maxima and minima is that m dy by dx is equals to tan zero, that is zero, that the slope of the graph at that point is zero, right? Okay. Now moving on, what we have, a point of maxima and minima. So the gradient we know m is equals to dy by dx, angle formed from the positive direction of x-axis is positive and is negative. Okay. I don't see the point of this discussion. So when the slope changes its sign, like from positive to negative, there is a point of maxima and there is a point of minima at these points. Okay. So first derivative test for maxima and minima, it is very easy. If the slope was positive initially and went negative, that means it was a point of maxima, because first the graph was increasing, then went decreasing. So that is, the slope would look like something like this. So it is positive. So it is a maxima. But if the graph was decreasing and then then went on to increase, so it is a point of minima. These are very basic things, guys. Like you must have done these in your classes and while preparing for JEE as well. So let's see how what the further detailed analysis looks like. So the procedure for to find out point of maxima and minima by second derivative test. Okay. Yes. So we did the second derivative test in the previous class as well. So what is the second derivative test? The second derivative test is that first condition, you check the first condition is dy by dx is equal to 0. But to find out that if it is a point of maxima or a point of minima, what we do, we calculate the second derivative of the function. And what is the second derivative function? It is d square y by dx square. And if dy and that comes out to be negative, right? For the above, if for the above any value, it is That maxima. If it comes out to be positive, then it is a point of minima, right? Okay, let's move on. So what we have here is, if we have the double derivative equals to 0, then what we do with the derivative, right? Yeah. So see here, it is a bit complicated to understand what is it is trying to say. That odd difference. See, first you differentiate once, it's fine, but excuse me, excuse me, but once you differentiate it twice and again you differentiate it thrice, so it can see third differentiation won't give us much information. If third differentiation is positive or negative, the point would not be maxima or minima, like it won't satisfy the equation, like it is not a condition that can give you an absolute answer. But if our third derivative is 0, then there is a possibility that point can be a maxima or minima. So what do? We check the fourth derivative and see if the fourth derivative is negative, then the point is maxima. If the fourth derivative is positive, then the point is minima. Okay. So moving on, find the dimensions of a rectangular field with the maximum area, which can be fenced by 36-meter fence. Let's solve it out. 36 is the fence, so 36 is equals to twice of length plus breadth. So L length plus breadth becomes 18. Area, right? Is right to you. So 18 minus L is to be differentiated LL. I'll just erase minus L, then differentiated with respect to this is area, and we differentiated with respect to L to get the maximum of it. So this becomes 18 minus 12, and we'll put it to 0, so L comes out to be 9. So it is 9 into 9. Right? This is what we have done in the question. If you can see, we took length is equals to x and breadth is equals to y, then further see what is to be done and what not. Okay, so you can go through the solution by yourself if you want to see the formal solution. So this is what the solution look like. Okay, so let's move on to the next question. The next question, these are like the simple questions to just give you an idea what maximum minimum could like do for you and what kind of questions might come. These are comparatively easier questions. We are starting with easier questions. So a cylinder has a fixed surface area. Establish a relation between the radius and height for which the volume is maximum. Okay. So what is given to us? Surface area is constant. So we don't know what surface area is constant, right? So we'll take the complete surface area. So what is the surface area here? Pi r square h plus 2 pi r square. Is the area? No, this is not the area. This is the volume, guys. What are you doing? This is 2 pi r h. And this is constant. So we'll put it is equals to K, right? And the volume is pi r square h. Okay. So we can write, hopefully, let's do one thing. Let's we have we have to do this, right? So Okay. So guys, there might be an internet issue earlier. So we were solving problem two. So I'll brief you the problem one. So what was given to us, that a cylinder was given to us and it had a fixed surface area. So surface area is 2 pi RH and 2 pi r square. So the curved surface area and the flat surface area. So we took it as a constant is equals to K, and we had to maximize the volume here. So what is the volume of a cylinder? Pi r square H. And if we have to maximize the volume, so we'll have to differentiate it with respect to a single variable. So what we did was we calculated H in terms of R and tried to put the value of H in the volume formula. We did that. And then we did the calculation. So what came to us was, for maximizing the volume with respect to R, R's value should be K by 6 pi, right? So what is the question exactly? Establish a relation between radius and height. Okay. So radius is equals to K by 6 pi. So what we know the value of K, right? K is 2 pi R square plus 2 pi RH. And this is by 6 pi. So we'll cancel out the pi, we'll cancel out the 2 factor. So we are left with R square plus RH by 3 root is equals to R. So it is R square, 3R square is equals to R square plus RH, 2R square is equals to RH, 2R is equals to H. Oh, sorry, yeah, it is 2R is equals to H. So it's easier. If you guys might have missed it, you can like see what the form like solution says. So the solution has taken S as their surface area and V as their volume, standard symbols, and then they differentiated volume with respect to R, and then got their uh, relation with R, and that is exactly what we did. Okay. Okay, so let's go a bit of theory and understand what maxima and minima could do for us. So let's read. For marketing purposes, we require vessels of different shape for which fabrication cost is less, but they could contain more material. Okay, so these have various application, guys. Usually the container part these are talking about. So what we try to do is the like जिसका बनाने का हमें cost कम पड़े, but वो सामान भी ज्यादा store कर पाए. That is what our usual requirement is, right? So for that purpose also we use the maxima and minima. For getting a more rectangular land area, when the perimeter land is given, okay, this is one of the conditions where we use maximum minima. In factories using resources so that the fabrication cost of the commodity become less. This is also very true. Okay, so now let's see more mathematical aspects of maxima and minima. So as we talked about what a maxima and minima is, so as you can see, here is the Q point, right? This Q point. So this is the point of a maxima, this is maxima, T is minima, R is minima. Okay. Okay, so let's see the mathematical definition of a what a maxima and minima looks like. So if y is a function given to us, and if f of a is greater than f of a plus delta, and f of a is greater than f of a minus delta for all values of delta, the point A is called the point of maximum of the function. Okay. Similarly, we can define the minimum. You can read what how we have defined the minimum once. I'll give you a minute. Okay, so it is very similar to maxima, right? Now extreme points. The points of maxima and minima of a function are called extreme points. These points, f dash x is equals to 0 if f dash exists. Cool. See here, there is also a point of decreasing and increasing. But since f dash x does not exist here, so at the point of at the point of extremum must be one of the critical points. However, there may exist the critical point which is not a point of extremum. Yeah, this is very true. So there are instances where f dash x would be zero, but this won't be a point of maxima or minima. One such example that we did the other day was a point of inflection. If you guys remember, you can check out the lecture, like what we did. I have discussed the point of inflection there as well. So we can see what the point of inflection is, and that is very similar condition to what it has been stated here. Okay, so let's check out some theorems related to. So theorem one says that yeah. So let's by first to fx be continuous in if f by x is zero, then x then x not zero. Hope this is similar to what we had. Basically, just a minute, guys. There's a network issue, I suppose. Okay. So I hope my screen is visible again. Okay, so we were discussing what a maxima and minima is. So let's see. So greatest and least value. So the greatest or least value of a continuous function f of x in an interval a and b is attained either at the critical points or at the point of interval. Okay, this is very interesting. We have to like understand it what is the greatest and least values look like, right? So let's also obtain the values of f of x at these points and compare them to the greatest and least values in the interval c. Yes. So what do we mean by this? So कोई भी greatest value or least value किन किन points पे exist कर सकती है. So the first criteria that we have here is that it could either be at the end points. अगर कोई continuously decrease, okay, we'll change the pen. अगर कोई continuously decreasing graph है ऐसा, it's not continuously decreasing, right? I draw the wrong graph. Let me draw it again. Okay, if this is a graph and कोई ऐसा graph है, so it is a decreasing graph, right? So अब यहाँ पे maximum होगा और यहाँ पे minimum होगा क्योंकि decrease कर रहा है graph. तो वो स्टार्टिंग में ही मैक्सिमम रहेगा और एंड में ही मिनिमम रहेगा, राइट? बट देयर कुड आल्सो बी अ कंडीशन लाइक कि वो हमेशा इंक्रीजिंग नहीं है, ऐसा ग्राफ है, तो यहाँ पे अ क्रिटिकल पॉइंट वुड हैव अ मैक्सिमम और मिनिमम वैल्यू. सो अपन व्हाट अप्रोच वी टेक हियर इज कि we check out the value of the function at critical points and at endpoints and compare them like by ourselves. If the endpoints have a maximum value, that would be the greatest, or if the critical point have the maximum value, that would be the greatest value. Twenty-four eight x square minus 45x. That's it. Right? So we have to find the derivative of this. So say, let's take the minus sign common. Minus 3x can be taken common, right? X square plus 8x plus 15. If I'm not wrong, it gives me x plus 3 and x plus 5 into x into minus 3. And if we put this into 0, what we have? X is equals to 0, minus 3, and minus 5. Let's calculate the value of the function at 0, minus 3, minus 5, right? So at 0, the value of f of x, f of 0 is 105. F of minus 5 would be really negative, would be greater than, would be less than f of minus 3, right? This is easy to understand because there is a power of 4 here, right? So I think that would dominate in any case. It is understandable, right? Let me write it. So this is a fact. So let's calculate f of minus 3. This is what they've done. This is what they've done. Yes. Yeah, the one thing would we could also do is we can calculate f double dash x and find out the values at these points. So it's giving us a maximum at 0, minimum at minus 3. Yeah, it's very easily done. And a maximum at minus 5. Okay. I hope you understood this question, guys. And it can be a bit calculative. So what, rather than comparing, what we could do is we calculate the double derivative and see what are the derivative values of these. So you can check out the solution by yourself for a minute and we'll move on further. So that the total surface area of a cuboid with a square base and a given volume is minimum, then it, when it is a cube, sorry. Okay. So the total surface area of a cuboid with a square base and a given volume is minimum when it is a cube. Okay. So see what we have here is we have been given this somewhat like this. It is a cuboid and it is a square base. Okay. So we have to minimize the volume. So how do we minimize the volume? The volume is a square b. And we have to minimize it. So surface area would be like this. Minimum surface area, we have a condition. Okay, yeah, it's very easy. Okay, so now I think you might have understood. See, maximum and minimum is not that of a big huge topic. So there is not much theory to there, but we could do some questions and find out that what does it look like. Let's calculate the second question. The first part is theory, so I'll leave it for you guys. I'll do the second for you. The shortest distance between the line and the curve. Okay. So let's plot the curve. It is x is equals to y square. What would this look like? At x is equals to 1, this would be 1. At x is equals to 2, it would be 4. So it is somewhat like this, isn't it? Okay. So another, I'll redraw it, I suppose. Okay, we are good. Now at x is equals to 0, y is 1. At x is equals to 0, y is 1. And at y is equals to 0, x is minus 1. Guys, it is an intersecting graph. What is this question, guys? I think there is a problem in this question. It is this, because at x is equals to 0, we have y is equals to 1. And at y is equals to 0, we have x is equals to minus 1. So it intersect कर रहा है graph को, so it is not correct. Let's check out the solution once so we'll get an idea. Is it the given question correct or not? No, guys, it is a wrong solution. Sorry, but I don't know what they've done here. Let me get back to you over this. That what do we mean by the shortest distance between the line and the curve? Because they are intersecting, right? If we take x is equals to y square, so what is y minus y square is equals to 1. So y square minus y plus 1 is equals to 0. So it is b square minus 4 it's negative. Yes, it should not exist. But where am I going wrong then? Is it this graph? Yes, we have drawn the graph wrong, guys. Okay. So what we have here is this is it, and this is the line. Okay, got it. Let's solve it from here. So one thing what we can do is we can find the tangent here with the same slope and see the distance between those 2 points. It would be very easy to calculate, right? Because we can calculate distance between two parallel lines. That is a very easy question for us. Or what we can do, that we can take a point. No, let's go with the tangent method. I think it would give us the result faster. So let's calculate it. So what is the slope of the line here? The slope of the line is 1. So we have to find a tangent here. So dy by dx, what does dy by dx look like? Let me see. So it is 1 2y by dx. So 1 by 2y is equals to dy by dx. And that should be equals to 1. So y comes out to be 1 by 2. So x is equals to y square. So x is equals to 1 by 4. So the point here is 1 by 4 comma 1 by 2. And I have to calculate the distance between these 2 points, right? Okay, so let's do this. So the equation of this point becomes, I think it is an easier way to solve this now. Let's just see the easier method and then move on. Okay, so what they have taken is they have taken a point. Okay, that is also okay, understandable. So what they have done, I'll tell you. Let's do this method. This is a new way of solving, so you guys might get an idea of how do we solve these types of questions. So yes, so what they have taken here is this is the parabola and this is the line. So they have taken a point t, comma t square, and the distance they have calculated the distance of this from this perpendicular distance, right? We'll check out the perpendicular distance of each point. So let's see. There is a point t comma t square, and we have to calculate the perpendicular distance. So how do we do that? Y, we write minus x plus y minus 1 is equal to 0, or x minus y plus 1 is equal to 0, and we put these values here. So we have t minus t square plus 1 root over 2, and this is the distance d of d, and we minimize this. So 2t. Yeah, that was really easy, guys. So in the solution that we were taking up, we already knew that the point was 1 comma 4 and 1 comma 2. And we have to find the perpendicular distance from this line. So we can simply apply the formula here. What do? We write 1 by 2 minus 1 by 4 minus 1 root over 2. I will double root 2. So we have this gives me 1 by 4, this gives me 3 by 4, so it gives me this. 3 by 4 root 2 or this. 3 is the answer. Let's check it once. Of course, we are correct. Let's move on to the another question. Let's calculate the third question. These are not JEE questions, guys. These are like AI triple E questions. So these might be a bit tougher than JEE mains question especially, but why not? We are here to practice, so let's go with it. So what is given to us that the function is defined from real to real, and it is given that the function looks like it has a parted question. So we have done this. Now we'll take it out and the this solution. So if f of x is a local minima at x is equal to -1, then the possible value of k is okay. So what do we do? Calculate f dash x. It gives me -2, and this gives me 2. Right. So let's plot the graph. At x is equal to 0, y is 3, and at -1 we have a minima, right? So first of all, it should be a continuous graph for it to be have a minima there. So it should have equal values, I suppose. So at -1, what is the value? 1, and at here, so it is k minus 2 should be equal to 1. So it should be 3 here. 3 minus 2k. No, it's incorrect. It is plus here. So it should be k is equals to -1. It is wrong. It should be 4 because first things first, right? They should be the function should be continuous to have a minimum there. So it is -1. This was very easy, guys. Let's see what is the answer. I hope it's not incorrect. It is correct. Continuous and less. So this is done. This is the same question, guys, that we did. Okay, so what are they trying to say that the question was repeated? It happens more than often, guys, if you see that the same question was given in 2009 and the same question was given in 2011. So it is very common to be questions repeated, especially in mathematics, right? Mathematics, chemistry, physics, questions may be repeated. Let's do a spherical balloon question, seventh question. So what we have here is a spherical balloon is filled with, okay, 4,500 pi cubic meters of helium gas. If a leak in the balloon causes the gas to escape at the rate of 72 pi cube meter per minute, then the rate in meter per minute. Guys, I have to read it again, it's too much. So we have we'll draw it out. We have a balloon, उसके अंदर 4,500 पाई का गैस है, उसके अंदर लीक हो रहा है और लीक का रेट है 72 पाई cubic meter per minute, right? Then the rate in meter per cube in meters per minute at which the radius. Okay, very cool. So what we have to find? We have to find dr by dt at t is equal to 49. It's as simple as that. No kitty we have to make and just completely understand what the question is saying. So let's start. So what is the volume? Volume is 2 pi this minus 72 pi t. It's as simple as that, isn't it? This is the volume. And the volume can be written as 4 by t pi r cube. Now intentionally given us pi, so we cancel out the pi's here. Okay. So what do I have to calculate? We have to calculate dr by dt. So let's calculate dr by dt. First, let's calculate what is r at t is equals to 49. So it is 4 by r cube is equals to 4 this minus 72 into 45. So this is sorry, minus 36 into 90, and this is minus 27,3240. If I'm not wrong. Yeah, it is 3240. So we have 60, 44 minus 32 is 12. 44 minus 32 is 12, right? So this is we have as. So let's cancel this. This is divisible by 4. It is divisible by 4. 3, 1, 5. So r cube comes out to be this 945. Now we calculate the rate. So the rate is 4r square dr by dt is equals to minus 72. So dr by dt is equals to minus 72 by 4r square. And that is equals to let's cancel the 4 here, minus 18 by r square. So it is minus 18 by 943 to power 2 by 3. Why am I not correct, guys? Let me see. Let's see if what is the cube here. 189 9. Let's take 9. But this is not correct. Let me check out the solution. We have question number 7, right? Okay, this is nice. Okay. This is also okay. Okay. There is something wrong in the solution. What they try to do, they have calculated the change in volume. We did the exact same thing. This is still here. We are bang on. Now to calculate the R, what they've done is R. Where did the 18 this come from? I don't know. So this is something wrong, guys. This is not the correct solution. I'll tell you why. Because what they've done, they have simply integrated it, but we do not know the R here, right? No, this is wrong. How did they come up with this? Okay, this is right, guys. This is right. I'm wrong here because R is not to be calculated the way I calculated it. It's wrong there. If we calculate the R that way, then we do not have a function of R initially. So this is not correct. The part that I explained that was not correct. This is the solution that is given is correct. Sometimes these kind of mistakes, of course, happen in our examinations as well. That we go through a direct approach, but sometimes the solution is not correct that way. So I'll warn you to be careful next time and see that if the solution that we're taking up is correct or not. Let's see some another question. So we can do this 13th question. 20 meters of wire is available for fencing of a flower bed in the form of circular sector. Then the maximum area of the flower bed is. Okay, so probably what I have, they have given me sector. So what do we mean by sector here? Yeah, see, sector is different. Sector is this. Right, so we'll solve with sector. These things are very important, guys. Like if we have taken a circular, like simple circle, so it won't be correct. We have to take a circular sector. What does a circular sector look like? This theta r. So the parameter is theta r plus 2r is equals to 20. So theta becomes 20 minus 2r by r. And the area of the sector is theta by 2 pi into pi r square. So pi and pi cancel. So theta r square by 2. And we know what the value of theta is 20 minus 2r by r into r square by 2. So we cancel the 2's here. So 10 minus r into r. Right? This is our area and it has to be maximized. So r has to be 5. And the maximum area we have as pi r square by 2. So theta at r is equal to 5 would be 20 minus 10 is 10, 10 by 5 is, so theta becomes 2. Theta is 2. So 2 phi square by 2, so it is 25. 13th has the answer is 4. Fourth option. Yeah. So you can check the formal solution as well. So what we did was, we know what a sector looks like. A sector looks like somewhat this. And this length, usually we approximate it to be as r theta, right? You know what the perimeter of a circle is? The perimeter of circle is 2 pi r. What is the 2 pi? 2 pi is the angle that the arc subtends, right? So here also we take theta. So the total length, total perimeter of the arc becomes 2r plus r theta. And that has been given in the question is equals to 220. So we can calculate the theta, the area, and then the further question is solved. Let's see comparatively easier question. Let's do 10th question. 10th is also a nicer question. Yes. So if x is equals to -1 and x is equals to 2 are extreme points of f(x) this, then. So what do we mean by extreme points? So the condition that we have for extreme points is that the single derivative is equals to 0, right? So we'll apply that condition here and take the single derivative as 0. So let's apply it and see what the single derivative looks like. So see, for x is equals to -1, let's go through the solution and understand it step by step. Okay. So double derivative we calculated. Okay. So putting it as x is equals to -1, what do we get? We get this equation. Putting x is equals to 2, what do we get? This. And solving both of these equations gives me the value of alpha and beta. It is comparatively a very easier question. If you want to me solve it physically, we can solve that with that way as well. But I think it's an easier solution, so we can leave it. If you have any doubts, you can put it in the comments. I'll try to solve it there. Let's go through another question. Let's go this. Real number k for which the equation has two distinct real roots in, excuse me. So two distinct real roots is 0 to has in 0 to 1. So if it has two distinct real roots in 0 to 1, so first condition is that f of x has to be positive. So see, if this is 0 and 1, so having two roots would look somewhat could look like this or like this. This is the least condition, right? Two distinct real roots. Sorry, I drew the same graph. That was not my intention. It is 0, 1, so it could look like this. So we're going to apply both of these conditions and see what is coming true for us. So first thing would be at 0, right? At 0, it should be positive, and at 1, it should be positive. But at one point, it should be negative, and the slope should be equal to 0. Let's see how they're trying to approach in the solution. We'll see it step by step. Yeah, the ninth question. So we have an f dash. Okay, they have calculated the f dash x and it's completely increasing. So f x is equal to 0 exactly has one root. Okay, so the answer would be not possible then. Does not exist because it is an always increasing graph. It was a tricky question. It was a trick question, not like something that had to be solved too much. Let's go through another question. This question. This question. We have done. This question is also done, not done. So let's go with 8. So let a and b be real such that the function f given by f of x equals to ln x plus bx squared plus ax, where x is not equal to 0, has extreme values at x is equals to -1 and x is equals to 2. F of x has local maximum at x is equals to -1 and at x is equals to 0. Then what is the value of a and y? Okay, that's very easy. What we do here is we calculate f dash of x. Let me calculate that for you guys. It would be 1 by x plus 2bx plus a is equal to 0. right? And putting the value -1 here, what do we have? -1 minus 2b plus a is equals to 0. And putting the value of 2 here, we have 1 by 2 plus 4b plus a is equals to 0. Subtracting these equations, we have minus 3 by 2 minus 6b is equal to 0. So b turns out to be minus 1 by 4. And if b is minus 1 by 4, then -1 plus 1 by 2 plus a. So this is -1 by 2. Yeah, this is right. Third option is correct. 8C. Let me see. Yeah, that is correct. Okay, so let's move on to another question. Do we have time? Yeah, we have time. So let's see what the another function looks like. Let's calculate the 14th one. 14th one is a nice question. If f of x is given to us x squared plus 1 by x square, and g of x is given as x minus 1 by x, for x not equal to -1, 0, 1, 1, okay, and h of x is defined as, then the local minimum value of h of x is. So it's an easier question again. So what we do here is, we try to calculate first, right, what h of x looks like. So h of x looks like x square plus 1 by x square upon x minus 1 by x, right? So if we write -2 and +2 here, so what are we left with? We are left with x minus 1 by x whole square plus 2x minus 1 by x, right? And again, x minus 1 by x here. So we cancel this out and we have x minus 1 by x plus 2 upon x minus 1 by x. So let x minus 1 by x is equals to t. So what we are left with, t plus 2 by t. Now we have to calculate the local minimum. So let's differentiate it. 1 minus 2 to the power -1. So it's t to the power -2. And again, hold dt by dx. So 1 plus 2x minus 1 by x whole square into 1 plus 1 by x square. This term is always positive. This is always positive. So it's an increasing graph, always increasing graph, I suppose. Yes. Let's check out 14th question. This what we did exactly. They have used, in what they have done here is they've used AMGM. So if you have studied arithmetic progression and geometric progression, so there is a simple solution that we have, that a plus b is always less than equals to 2 root ab, right? So here we take t plus 2 by t into 2 by t. So t c t cancel and 2 root t. But sorry, this is the case. But since these terms are negative, we reverse it up. And that is why we get a value. But there is another technique also. We can put it equal to 0 and get some values out. Let me see if we can do that. Actually, we can do that. Okay, this is an whole multiplication now. This equals to 0. So this won't be 0, but this would also not be 0. Guys, we are doing something wrong here. Just a minute. Let's rectify our process. This is absolutely correct, right? There would be a minus sign here, guys. We missed the minus sign. There is a minus sign here. So yes, we can solve here. So it is 1 equals to 2 by x minus 1 by x whole square. This would go here. So x minus 1 by x whole square would look is equals to 2. So x minus 1 by x is equals to root 2. This is the equation where there would be a minimum. So we can calculate it. So we had our equation as t plus 2 by t. And this was our t. So root 2 plus 2 by root 2. 2 root 2. Third. And this is the correct answer. Right? Let's move on to another question. We have done this. We have done this. We have not done this, right? So let me erase all this and get some clear space. Okay. So wire of 2 units is cut into two parts which are bent respectively to form a square of side x units and a circle of radius r units. If some of the area, okay, it has to be minimized, right? So let's take, okay. So we have 2 pi r plus 4x equals to 2. And their area is minimum. So pi r square plus x square has to be minimized. So let's cut the two factor here and we'll x becomes 1 minus pi r. So pi r square plus 1 minus pi r's whole square is our area and has to be minimized. These other parts. Where am I? Yes. So let's calculate it. So it is 2 pi r plus 2 times of 1 minus pi r and minus pi. This should be equals to 0. So let's cancel out the pi factor and 2 factor. So r becomes 1 minus pi r. So this becomes, and now taking a double derivative, we have 2 pi minus 2 pi and minus pi. So minus minus gets cancelled and we have 2 pi plus 2 pi square upon 1 minus pi. And I think this is a negative term. So it is always negative. So it is a problematic question, but I think this would suffice. Then I have to, what do I have to find? I have to find the relation between R and X. Okay. So that is the already established, right? So as we can see that it was cut into two pieces, right? So 2 pi r plus 4x. Let me just go through the solution one. So we'll go through it step by step. Okay, this is exactly what we did. Then we calculated r, okay, and then the area. Okay, so we got this relation, right? So this is understandable. And this was the solution, guys. Also, there are different questions that are available online also, so I'll suggest you to go through the PYQs by yourselves once, and we can continue and have a more further. Let's see if we can complete this question in a minute or two. So if this is given to us, right? So what they have calculated f of x, then they have calculated f dash of x, then they put a zero, then they calculate the double derivative and checked if it is negative or positive. But it was positive at 2, so it would be a minima, but at 4 by 3, it was a maximum value point. So we calculated f of 4 by 3 and got a value of 4 by 27. So these kind of questions are very direct. What are you have to do is you take the single derivative, put it to 0, then check the double derivative. If it is negative, then it is a maxima. If it is positive, then it's a minima. So I hope this clarifies things for you. And if any further doubts you have, kindly put them in comments and I'll try to solve those for you guys. But this was maxima and minima. It's not a very difficult topic to understand, but if you practice to a certain extent, you might be able to crack it questions that come your way. So yes, I'll end the session here and see you over next classes. Bye.